I look at iOS 9 today, and it still doesn't do that, so I'm going to show it. Basically, in iOS 7, there's something new, which is that the toolbar actually does blur. So if you have content beneath a toolbar, actually the toolbar is not totally opaque. It actually shows something through, and it's blurred. So around that time, me and a friend of mine went out to look out for the perfect blurring view, and we weren't able to find it. So we built our own. And iOS 8 came out, and there was this thing called the UI effect view, where you can choose between 3 different levels of blurring, which was not enough. So this project got to live for another year, and then iOS 9 came out, and still only 3 levels of blurring. So this project gets to live another year again. So I'm going to show it. Basically, it's a very simple view, which you can put over any kind of other views that you have in your application. We call it a glass view, which is a blurry thing that you can put somewhere. Hopefully it builds. And yeah, it does. Okay, so basically what it does is that this is a collection view where I use some kind of randomization to spawn cells of different colors, and then there are about I think about 1,000 cells there. So they're of different colors. So I can have a base to work with, and then assuming I have my cursor here, this thing over that collection view is a glass view, where whenever you interact with the application, the glass view automatically blurs whatever beneath that view. So ideally, you just want the glass view to be the topmost view in your view hierarchy, and it would work automatically. And the way it works has been tuned to the way that if blurring takes more than 16 milliseconds, it would silently drop frames in blurring, but it wouldn't impede your application's frame rate. And the way you do that is pretty crazy. Basically, you do dispatch async on a queue, and you check the results. If it doesn't come back, then you know you have to drop a frame. It's it's so crazy, but it's in the source code. That was like literally the only way you can do it without impeding performance. So this thing basically is very simple. You just take it and you drop it into your project, and you have your blurring view. But that's not all, because this thing actually gives you 2 parameters that you don't get from Apple. The first one is that hopefully I can enlarge the text, and I'll try doing that right now. Should be presentation. It doesn't actually enlarge anything.
There's presentation large.
Oh, yeah, right below this presentation large.
Oh,
Okay.
that's presentation too large.
It's better than too small, I think.
That's good.
Yeah. So basically, the API is very simple. It gives you 2 things. One is the blur radius, and another one is the scale factor. So the blur radius determines the blurriness of a view. Currently, we have our blurriness set at about 4, I think. So this is your view controller, where you interact with the blurring view, and you can spawn a glass view here. So let's say we want the blur radius to be 1. So change it to 1, and it will work. Then you can see it's slightly less blurry. But if you change it to, let's say 16, then it will be more blurry. So in order to prove that I'm not just bullshitting you, that it actually does work, I'm going to find a video a few years ago captured somewhere like on an iPhone 4S, which is like the lowest end device you need to support today. So hopefully I can find it. Well, if I can't find it, then we don't have it. And yeah, I cannot find it. But it's available somewhere on GitHub. So if you go to GitHub and search for Live Frost, then you will find it. And hopefully the video will be there.
scale factor here?
It determines the size of the blur kernel that we feed into the actual algorithm. So I can probably actually disable mirroring, which will make it much easier. No, it does not. Okay. So blur kernel here. Basically, some math here. And the size of the blur radius determines the size of the blur kernel, and then you use that value, you feed that into a box convolving algorithm. I think, yeah, it's called the image box convolve. Basically, for each frame, we hide the glass view, and then we take a snapshot of the window, and then we feed that image into the image box convolve, and then we do it 3 times. Because empirically, if you only do it 1 time, then edges are jagged. And if you do it 2 times, sometimes it's unstable. But if you do it 3 times, then it looks fine. And if you do it 4 times, it doesn't look much different. So we do it 3 times. And then the final result will then be put into the content of a layer, which is held by that view, which is basically the final result, which is a blurred image. And I think the blurring thing also is triggered by something. I think we call it our display link somewhere. Basically, it's somewhere called a display bridge. And this thing is where the hack is, where you can spin out a display bridge, and you tell the bridge to trigger you whenever you can draw. And this is so annoying. Something here. So, well, display link tells you when you can draw. And then when you can draw, you draw it.
Does it blow when the screen is changed? Or
Yeah.
does it just blow this?
It will just redraw and redraw and redraw every time. But there is a way to infer if you really want to infer, which is that the NS run loop, the main run loop, changes modes whenever your user is actually touching the device and tracking, enters some kind of UI run loop tracking mode or something. If you really want to conserve battery life and you know that your content actually is static, then you can also listen for that and control the glass view and just remove it from view hierarchy whenever you don't need it or something. Or pause it, and that will probably save you a lot of battery life. But I haven't tried it. So there must be a video somewhere, which I cannot find it. I just cannot find it. Yeah, I can't find it. But you just have to take my words that it works correctly on an iPhone 4S at 60 frames per second with a collection view in iOS 6. Thanks.